Today we're going to continue working with exponents and radicals, developing our rules a little bit further. And just as a heads up, the next quest is coming up a week from Wednesday. Next week we'll have quest number 3, and it's going to be on classes 14 through 18, which is all of our exponent and radical stuff. Okay. So quest 3, week from Wednesday. Okay, so today we're going to talk about roots and radicals and rational exponents. Okay, we saw this in the previous lesson, and we were in the previous lesson, we said, well, if you're trying to take a radical of x to a power, you can do this division, just do k divided by n. That's how you take the radical. But we kind of got a little stumped when the index didn't go evenly into the exponent, right? But it turns out that that formula is true even if it doesn't go evenly into the exponent. So for example, if I wanted to take the 5th root of 8, right? 8 isn't divisible by 5, but you can still write x to the 8/5, 8 over 5. So a couple of ways to help you remember where the pieces go. If you're going from radical form to exponential form, right? This guy is radical form, this guy is exponential form because it's got an exponent. So the index, which is the 5, goes below deck. Index below deck, right? So it goes on the bottom of the fraction. And flowers grow up and powers go up, right? So 8 is a power and it goes up. It goes in the top of the fraction. Another way that I remember it is that roots go in the cellar, right? So 5 is the root I'm taking, the 5th root. And so it goes in the cellar, the bottom of the fraction, right? Because you guys know what a root cellar is, right? Yes, yeah, so in the basement where you put root vegetables. Yes, roots go in the cellar. Okay, so just a couple of ways to help you remember. So for example, I want to rewrite this guy in exponential form. So I've got a root, I've got an index, and I've got a power. I'm taking negative 2y, I'm raising it to the 13th, and then I'm going to take the 11th root. Okay. So if I were going to rewrite this as an exponent instead of a radical, I keep the negative 2y exactly as it is, right? And then I'm going to have a fraction as an exponent. And what's going to go in the top of that fraction? 13, right? Flowers go up and powers go up. So 13 goes on top. And then what goes on the bottom? 11. That's it. All right, and then if I wanted to rewrite x to the 2/7 in radical form, I'm going to have a radical. I'm going to have an x underneath. And then where do I put the 7? Out in front, that's my index. And where do I put the 2? On the x. Yeah. Is that okay? All right, so I'm going to evaluate each of these things by first rewriting in radical form. So I'm giving you exponential form. We're going to rewrite it using a radical and then see if we can answer the question. Right, so 64 to the 1/2. I've got 64 and a radical. Where do I put the 1? I don't, or you could say on the 64, but 64 to the 1st just means 64. So I'm going to put it there just so you know where it went, right? And where do I put the 2? Outside. With square roots, you typically don't write it, but you can if you want. It's not wrong. So this says the square root of 64. And what is the square root of 64? 8. Okay, very similar problem, except now the thing under the radical is negative 64. So this is the square root of negative 64. What number can you square and make negative 64? Well, 8 squared gives you positive 64. Negative 8 gives you negative 8 times negative 8, which is also positive 64. So it's not 8 and it's not negative 8. When you square 1 over 8, you get 1 over 64. I heard several people say it earlier. You can't do it. Yeah. There is no real number that when you square it, you get negative 64. So this is undefined. All right, but the difference here is that the negative is outside. The negative in this example is glued to the 64, right? In this example, I don't have parentheses that's telling me to glue it, right? So this actually says -1 times 64 to the 1/2. And I know 64 to the 1/2 is 8 because I did that earlier. So this is -1 times 8, which is -8. So you got to watch where the parentheses show up. If there were parentheses making that negative go with the 64, then you can't do it. That's like B, right? But because they're not there, that means do the exponent first, right? Before you do the multiplication. So you do 64 to the 1/2, you get 8, then multiply by -1. Order of operations, exponents comes before multiplication. Here, you do the multiplication first because it's in parentheses. That's a -1 times a 64 before you do the exponent. Yes? Yeah, if you're taking an even root, you will never be able to do that. Yeah. Odd roots, you can do that. Okay, we're going to do another one, similar, and we're going to do it 2 different ways. So if I have 8 to the 2/3, that means I'm taking a radical because I've got a fraction, and the 3, the index is the one that's below deck, so the 3 becomes the index. Flowers go up and powers go up, so that 2 becomes the power on the 8. And then if you take 8 squared, what do you get? So this is the cube root of 64. What number can you cube and get 64? 4. So this answer is 4. Okay. It turns out that you can do, here we did the squaring first and then the cube rooting. Yes? Oh, is there a typo? No, I was just wondering. It's probably a typo. Let me take a quick look.
No, there is a typo. Okay, I was just. Those 8 right there, Caitlin, where it says 64.
Yeah.
Cube.
Oh, they switched it to the 4th index. Yeah. That's a typo. You need to keep it a cube root. Yeah. Sorry, I didn't notice that ahead of time. Yeah, that is not a 4. Like your paper says. It says not 4. Right, it equals 4. Yeah. All right, so now in this example, we squared the 8 and then cube rooted. It turns out that you can do it in the other order and we should get the same answer. So in this case, I'm going to do the cube root of 8 and then square it. So I'm reversing the order. Here I squared the 8 and then cube rooted. Here I'm going to cube root the 8 and then square. What is the cube root of 8? 2. And 2 squared is 4. You get the same answer either way. Okay. So it doesn't matter whether you put the power inside the radical or outside the radical. You can't do it wrong. Right? If you're doing a numerical calculation, it's often easier to take the root first because taking roots of numbers is hard, and like we know some of the small ones in our head. Right? But it doesn't matter. And then this is just sort of the formula that we've just been using over and over and over again. All right, so let's complicate things just a little bit more. And we're going to put a negative in an exponent also. So in general, dealing with a negative exponent is a good first step. So if you have a negative exponent, get rid of that first before you do anything else. So I want to do 16 raised to the -3/4. So this is like a 16 to the -3/4 over 1, because negative exponents indicate movement, right? So I need some place to move it to, so I created a denominator with a 1 in it. So 16 to the -3/4, That negative indicates move to the denominator, right? So I'm going to have my 1 is down in the denominator times 16 to the positive 3/4. Once I move it, I can write the exponent as positive. Now, what's left in my numerator now that I moved that guy out? Just a 1, yeah. Because anytime you have something, any number, you can always write it as 1 times that number. So when the 16 to the negative 3/4 moves, there's actually a 1 hiding up there that it just wasn't written. All right, so this is 1 over 16 to the 3/4, which is 1 over. Now let's rewrite 16 to the 3/4 using a radical. So which number is my index? The 4, yep. The index goes below deck, right? So the 4 is going to be the index. Flowers go up, so powers go up. So 3 is my power because it's on top of the fraction. So I'm going to do the 4th root of 16 cubed. And I can put that cube on the 16 or on the radical. I'm putting it outside because I know what the 4th root of 16 is. If I cubed 16, I'll get a big number, and I don't know if I'll know how to take the 4th root of it.
Isn't some of that going to cancel out some of that? If we cancel out the 4 from the 3 and end up with 16 squared, and end up with the same number?
It wouldn't be 16 squared. It would be the 4th root of 16. No, it wouldn't. Nope. Nope, they don't cancel. Nope, we got to do it one step at a time. So the 4th root of 16, what number do you raise to the 4th power to make a 16? 2. 2 times 2 times 2 times 2 gives you 16. So the 4th root of 16 is 2, so I'm going to replace the 4th root of 16 with a 2. Still have to cube it. What's 2 cubed? 8. 1 over 8. And just to show you that it's the same, I'm going to do this where I do 1 over the 4th root of 16 cubed. So I'm going to do the cubing first instead of the 4th rooting. So 16 cubed, now I need to pull out a calculator, right? Before, the reason I did it in that order is because I could do it in my head. But now I need a calculator, which is fine. Okay, so I want to do 16 cubed, 16 to the 3rd. And I get 4,096. So this is 1 over the 4th root of 4,096. And then the 4th root of 4,096, I can't do that in my head. I have a list of perfect 4th powers, and they don't go up to 4,096. So I'm going to have to ask my calculator to do this. Your calculator can do it too. I don't have one to project, and you all have different calculators. So if you need me to show you while you're working on the activities, I'll show you. But on this calculator, I would go math. I need the xth root. So I'm going to take the 4th root of 4,096, and it says it's 8. Right, so this is 1 over 8. So you get the same answer, whether you do the power first or the root first.